Do you guys think the transformations are going to change for this log?
No.
No, they're not. All right. Never ever. Y equals. Okay, let me give you a standard format of a log. Your A times log will like that. If you have a base, where does the base go? The bottom. So here's a base somewhere below. Base is always a subscript, okay? Base of whatever it is. It can be 2, it can be 5, it can be 10, it can be a half. So A times log base of something. This something, let's call it X. Okay. Where do we put the H? With the X or outside of that? With the X. Do we minus H or do we plus H? Minus H. So this stays the same. And then where do we put the K? Add it right there. So the only subscript is the base. Okay. Now, what happened? A is negative. What kind of transformation is that?
Oh, reflect over the X.
Yeah, reflect over the x-axis. Okay. Next year you learn another type of reflection, but right now, reflect over the x-axis. Now, if A is less than a 1, like a half, a quarter, 11 over 12, what kind of transformation is that? A is less than 1, a quarter. Vertical, not stretch, but compression, right? Factor of whatever it is, factor of A. If A is a quarter, then it's a vertical compression factor of quarter. If A is bigger than 1, like 5, Daniel, if A is 5, what kind of transformation is that? That's right, vertical stretch. Factor of that value, factor of A, okay? H, what does it do?
It moves left to right.
Right, perfect. Left or right, depending on if it's negative or positive. K, Brandon C, what's K used for?
It's used to identify the A and H.
No. Pay attention. K, it's K used for?
It's like the value at the end.
Uh-huh. What kind of transformation is that? Up and down. Very good. Much better. Okay. Now, the steps for graphing, they are still exactly the same. That's why I don't even have you write it down anymore. Okay. We're just now going to straight up go all the way to example 2. Graph each function. Then find all of the stuff that we always find. Find all the characteristics. Example 2, y equals negative log base 2 of x minus 4 plus 5. We need to identify the parent. Anybody know what the parent function is? Y equals what? Y equals what?
Y equals log of x.
Log is perfect. Base 2 over x. You are correct. Remember, the base will be different, just like exponential. In exponential, bases are always different. Well, I need to make my table. X and y. Yes, Brandon?
Is the parent function going to ever change
It will?
for this one?
Well, the bases will change. If the bases are different, then you're going to have a different parent.
Where's the base of 2 and then?
If the base is 2 in the original, then the parents will never change.
But the base isn't 2 and then?
In what? In example 2? The base is 2. See?
Oh, so it's whatever the base is that belongs to the base?
Right. It's just like the exponent, right? 2 to the x minus 5 plus 7. Then the parent would be 2 to the x.
Like 73, the parent would be y equals log 73.
Log base 70. Yep. So whatever that is. So what the parent depends on the base. Okay. Okay. Now what? I need to make values for x and y. What do you do? What do we do? I converted. You're right. Convert to what? We said yesterday that we can easily go from what to what? Exponential to log and log to exponential. So what is an equivalent equation in exponential? 2. Beautiful. 2 to the y equals x. Okay. Remember, yesterday, we were doing that. We did one of those already yesterday. Let me move it down. Can you guys see this? This is the parent. This is the equivalent form right there. So just like yesterday, do we pick values for x or do we pick values for y? For y. All right. When we're going to pick the same values. Ready? Yes. Ask away.
For the parent, it's y equals log to the base of 2.
Log
x.
base 2 of
Log
x.
base 2x, right? So when you flip it, when you flip it, you're just doing like the base time to the power
Raised to power of y.
raised to the power of y.
Equals x.
Wait, so we start off with the y's instead of the x's?
Right, that's how we go from log to exponential. Like, see this right here? Let me move it back down from yesterday, huh? Okay, yesterday we did a bunch of rewriting back and forth, right? Can you see our equation? It says log base, the base is your b, right? Of something called a equals x. How do we convert that to exponential form? The base is still maintain a base. Would you agree?
Yeah.
In the log, it was equaling to x. But where did we put x when it was rewritten as an exponent form?
Right.
No. This is in log. When you rewrite it in exponential, where does it go? Where does it go? It's a power. Okay. So you got to be very comfortable with writing backward and forward. I can write it any way I want, right? So it depends on what you were given with. Okay. So here we are given y equals log base 2 of x. So we're going to write base 2 to the power of y equal to x. Okay. All right, plug it in. When y is negative 2, x to the negative 2, which is, 2 to the negative 2 is a quarter. 2 to the negative 1 is 1/2. 2 to the 0 is 2 to the 1. And 2 square. 4. Perfect. A value. This one goes to, what is our A value, Gemma? What's an A value here? -1. H value, please. This one goes to Brandon N. H. What's your H? 4. K value, Grace? 5. So now we're going to have an x plus 4, -1 times y plus 5. Let's work out our new x. Yeah.
The negative one comes from the negative from the log.
That right, because remember, the a is always in front of log. Okay. All right, let's work out our new values of x's. Okay. What's the first new value, Victoria, of x? Perfect. Second value of x, please, Maddie R.
4.5.
Perfect. Third value of x, please, Joe.
5.
Perfect. Next one, please, Lena. Last one, please, Chance.
8.
Perfect. Okay. First value of y, please, James.
7.
Perfect. Next value of y, please, Hunter.
6.
Next, please, Roger.
5. Wait.
Yes, no?
Yeah.
Yeah, broke. Next. And last, Amanda. Oh, no, Amanda. Where's Amanda? Not here. I didn't even take it in. Okay, Daniel. Last. 3. Who recalls where the asymptote was, the vertical asymptote from the parent? 0. Did we move left or right at all? 4. So where would you put it now? On 4. So we are going to have an asymptote, vertical asymptote, at x equals to +4. So right away, I graph my asymptote. Immediately as well, should we go in and write asymptote for which one? Horizontal or vertical? Vertical. X equals or y equals? X equals. So class, that means you're not going to have any horizontal, okay? Then let's plot the dots. Ready? 4 1/4. I need to go positive 7. It's going to be pretty close. The first two dots are normally pretty close. 4 1/2 is going to be 6. 5, it's at 5. 6 is not 4. And 8 is 3. Just because we have 5 dots, does that mean we stop at 5 dots?
No.
No, make sure you have arrows on both ends. Okay? Now, since I always forget the transformations, we're going to go straight down and write our 3 transformation first. Hope, the A being -1, what kind of transformation is that? Perfect. Reflect over x-axis. Carly, H being 4, what kind of transformation is that?
Shift to the right 4.
Perfect. Right 4 units. And Dylan, K being 5, what kind of transformation is that? Perfect. Good job, guys. Okay, let's go and find the chart, fill in the chart, okay? Delaney, H and K in the table here, what should we write? 4, 5, beautiful. X-intercept, do you think we're going to have any?
No.
Yeah, at some point you're going to have some. How come you know for sure you're going to have an X-intercept? It's going to keep going forever, right? Eventually it's going to cross it. But do you think you're going to have Y-intercept? No, so I can go in and write none right away. I'm going to do all the stuff I can do first and then go back and find X-intercept. What's the domain? 4 all the way to infinity. Is it okay to write X bigger than 4? Sure. What's the range? All reals. Is this an increasing or decreasing function?
Decreasing.
Decreasing, so I'm going to write NA for increase. Decreasing from where to where? Good. What do we write for the rate of change? Varies. What do we write for 1 to 1? Yes. Okay. Now, remember yesterday's homework. Okay. I asked you to put the star next to the x-intercepts. Remember this yesterday?
Yep.
Well, congratulations. Today, you are going to be able to find it.
Let's go.
Let's go. X-intercept is when the y value equals to what?
0.
0. So 0 equals negative log base 2 over x minus 4 plus 5. We need to solve for what variable? X, because I'm looking for x-intercept. What do you do first? Subtract what? 5 from both sides. So if I subtract 5 from both sides, I would now have negative 5 equals negative 1 times log of base 2 x minus 4. Now what? Next, that's our next step. What do we do now? I would need to divide both sides by negative 1. If I divide both sides by negative 1, I would now have a positive 5 equals what? Log base 2 of x minus 4. Okay. Say that one more time. Because the negative 1 is in front. So Brandon, this whole thing right here is 1. So there's a negative 1 in front of that. They're all together. It's like one big, chunk. One big ugly thing. Okay. So let me give you a warning. Guys, you may not, again, I'm going to repeat this multiple times. You may not distribute log. Again, you may not distribute what? Log. Okay. Don't go like this. That would be completely wrong because that's distribution. So I need to isolate x. I need to get x all by itself. I can't do it in log form. What's an equivalent form again? Expo. How do I rewrite that in an equivalent form?
2 to the power of 5 equals x minus 4.
Yeah. If I can't solve it in log, I'm going to solve it in exponential form. What's 2 to the 5th? 32. equals x minus 4. What's x then?
36.
See, now you can solve it all on your own, y'all. So the x-intercept is at 36, 0. Okay. Now you can find all things. All right, once you're done copying this down, go ahead and move to example 3. I'm going to give you a minute head start to see how far you can accomplish with 1 minute head start.
So what are we doing?
Moving on, we're going to finish all the graphing questions. Okay. Okay, here is example 3.
Really? 3 minutes start?
That's a 1/2. I would like for you to at least do the parent equation and the parent chart, okay? Do we know what the parent equation is?
The same as last time.
No. What's the parent equation? Y equals what? Log base 1/2 of x. What's our equivalency in exponential? Yes. The base, yep. You only strip away the transformations.
Nothing else changes.
Nothing else. What's the equivalency in exponential? Is it 2? 1/2. Remember, the base has to be the same as the log. 1/2 to the power y equals to x. Okay, do we pick x values or y values? All right, so fill in -2, -1, 0, 1, and 2. X is dependent on y in this case. Go ahead and fill in the 5 values for x, please, for the parent. Once you have the 5 values for x for the parent, can you just consult with your partner? So that way your x values are not incorrect. So talk it out. Find your x values group. Did you guys find the 5 x values for the parent? Emma H, can you give me all 5, please?
All 5 to x. 4, 2, 1, 1/2, 1, 4.
Do you guys agree? Beautiful. All right, let's find A, H, and K. A value, can you please give me the A value? This one goes to McKenna. Beautiful. H value, this one goes to AJ. 0. Can you give me the K value, Brennan C? Thank you. All right, there's only one transformation. The A being 3, so that's being multiplied to y. X stays the same. So immediately I can just copy the x over, right guys? Yeah. So Emma P, give me the 5 x values, please.
4, 2, 1, 1/2.
Perfect. Okay. Whenever you are ready, Kennedy, give me the 5 y values. Okay. The parent function normally has a vertical asymptote at where?
0.
Did we move left to right at all? So would we still have one at 0? Yep, let's go graph that right away. Okay. If I have an asymptote, I'm going to go over to my chart here and write x equals to 0 on the vertical asymptote, and immediately I'm going to write NA on the horizontal. Okay. All right, let's plot the dots. 4, I would need to go all the way down to -6. 2, 4, 2, 4, 6. 2, we are now going to -3. 1 stays at 0. 1/2 go to 3. And 1/4 go to 6. Okay. Did you have something similar to this? Perfect. Okay. How many transformations, Ainsley, do we have? One. What is that one transformation? Very good. Okay. Again, I'm going to give you guys another minute head start on the chart. HK, X-intercept, Y-intercept, all of that. Fill out the stuff that you can fill. Kai, do we have any HK? If so, what are they? Perfect. This one, Arista, do we have any X-intercept? X-intercept is when what, Arista?
When it crosses the X.
Good. I mean, Y value has to be?
1, 0. The X-intercept is 1, 0.
Right, because Y value is already 0. Perfect. Y-intercept, would you have any? No. Okay, none. What is the domain? This one goes to Ainsley. Mm-hmm. That's okay. Take your time. Remember, the domain is talking about all values of what? X. Where do you think the smallest value of X is?
Oh, yeah, smallest value is 1, 4.
Well, technically, could I have smaller than that?
Oh,
Yeah.
so
What value can you not have based on this graph?
oh, 0.
Right. So technically, I can have something
0 to
0, non-inclusive at 0, all the way to infinity. Good job. So domain 0 to infinity. Some of you like writing X is bigger than 0. Totally okay. Range, can you? Emma P, what's the range? Perfect. Kennedy, increase or decreasing?
It's decreasing.
Good. So we're going to write NA there. Decreasing interval. Can you tell me what to write, please? Brendan C. Decreasing interval.
Decreasing interval. You want to say 1 to infinity.
Close.
Oh, above 1 and infinity. 0 and infinity.
Guys, decreasing interval. Remember, the entire thing is decreasing, so it has to be the entire domain. AJ, rate of change. What do you want to write? Varies. I'm sorry, you have a question, Chance?
I was going to ask, is the domain and the decreasing value always going to be the same?
For this particular function, because this particular function is either increase or either decreasing. Okay. 1 to 1 is yes. Okay. All right, move up to example. Numero what?
Treso.
Quattro. Quattroso. Okay. Parent function. Can you please give me the parent equation, McKenna? So what's the equation for the parent and only the parent? Consult your team, hon. So just the equation for the parent.
Okay, 6y equals x.
Well, give it to me in log first. Brandon N., what is the log equation for a parent?
Y equals 1 base of 6 to the x.
Log base 6 of x, right? Do I add anything? Do I subtract anything for the parents? No. But in log, okay, if you can find the x and y values for in log form, go for it. But technically, I can also write an equivalent equation of that in exponential, so it's easier for us to plug in values. So this one goes to Emma H. What is an equivalent equation for that in exponential?
6 to the power of y.
Perfect. Okay. Find x and y chart. What do we pick values for, Dylan? Do we pick values for y's or x? Right. So we're going to use -2, -1, 0, 1, and 2. Okay. I'm going to give you 30 seconds to find the x values, all 5 of them. Just the x value of the parent, okay? And then I'm going to start with the parts. If you found them, consult with the team right away, please. All right, Grace, do you find all 5 x values, hon? Okay, work on it. Consult your team. Once you're ready, give it to me. No, give it to me in fractions, hon. Yeah. One over? Is it 1 over 12, y'all? 1 over what, y'all? Much better. 1 over 36. What's next, hon?
1 over 6.
Perfect.
1 and 6 over 36.
Beautiful. Good job. A, H, and K. James, what are those? A, H, and K. Give me all 3. So 1? Yeah. Uh-huh. H is -4. Good. Good job. Okay. So I'm going to do x minus 4. I don't need to multiply y by 1 because it's not going to change. So I'm just going to add y with 3. All right. Go ahead and take your time to find me 5 new x's and find 5 new y values. Once you're ready, okay? Roger, give me all the 5 new x values when you're ready. And give it to me as fractions, okay? And then Hope, when you're ready, give me 5 new y values, okay? One, 2, 3, 4, and 5. You guys agree? Okay. Just waiting for x's, okay?
-3 and 35 over 36.
Good job.
-3, 5 over 6.
Beautiful.
-3, 2, and 32.
Great. We used to have an asymptote at 0. Daniel, where should we start graphing our asymptote now? Good. Go over, graph it at -4. That means I'm just going to straight up go over and write x equals to -4 on my VA and write none on my horizontal asymptote. Then I'm just going to plot my 5 dots. -3, 35 or 36, up 1, super close to the asymptote. These 2 dots are going to be pretty close to each other. -3, up 3 is now this guy right here. As you can see, the dots are super close to each other. +2, go up 4. I don't have 32, so I'm just going to use those 4 dots. But that is enough for me to get a nice log graph. Okay, let's fill out the transformation because I always forget that piece. Hunter, h mean -4. What kind of transformation is that?
Translation left.
Okay, so left 4 units. Good job, Hunter. Then we have a k, Carly, being 3. What kind of transformation is that?
Shift up 3.
Perfect. Then h and k, let's fill this out. Arista, what are h and k, please?
-4 and 3.
Good. Perfect. Do we have any x-intercept?
Yeah.
Yeah, I'm going to find that later because I need to do some math, right? Do we have any y-intercept? We'll find that later as well because I need to do some math. What's the domain right now, Lena? Good. -4 all the way to infinity. What's the range right now, Brooke? Good. Is this, Joe, increase or decreasing? Increasing for where to where, Joe? Good. That means decreasing. We're going to write none. Rate of change, we are going to write varies. 1 to 1, we write yes. Now, we have to do some basic algebra for our x-intercept and also our y-intercept. All right. X-intercept, we know already, is when y equals to 0. So 0 equals log base 6 of x plus 4 plus 3. We have to solve for what variable, Maddie?
X.
Good. So what would you want to move first?
Subtract 3.
Good. -3 equals log base 6 of x plus 4. The log is already isolated. We cannot distribute log. So how do we go about solving for x now?
We turn to exponent.
Exponent it is. 6 to the -3 equals to x plus 4. Right, Brandon C?
Yeah.
Okay, Brandon C, what's 6 to the -3?
X plus 4.
No, what is 6 to the -3?
It's 1 over 216.
Good, equal to x plus 4. What is our last step chance in solving for x?
U -4.
Good, so 1 over 216 minus 4 equals to x. X comes out to be a pretty nice value. -3 and what, y'all? That's right. Okay, so that's your x-intercept. I'm going to fill that in. X-intercept is -3, 215 all over 216, comma 0. Now we got to go and find what?
Why?
Y. Brandon C, what's up?
So, could you find it another way also?
Like what, hun?
So you see like where the points are?
Uh-huh.
So could you just put y at 0 right there? Like go 1 back basically and then have 6 to the power of 0, wouldn't that be 1?
6 to the power of 0. What do you mean by that, huh?
Well, what is it?
But that's the parent function. Remember, we're solving for the non-parent. So, and we can't eyeball it. AJ?
Wait, so for the parent function, if we put -3, like if we use -3 for the parent function, would that have given us the x-intercept on the
-3? What do you mean by that? What do you mean by when you use -3?
Like, you know, on the y value of the parent function, how it's -2, -1 on the parent function. If you use -3 as well, and then after you transform, the y would be 0. So wouldn't you just have the answer for the x-intercept if you did that?
No, because you have something very ugly.
Yeah, you get the same thing.
So when you use -3, yeah, that's fine. Yeah, totally. Yes, if you pick something else, totally.
So if we know that our k value is 3, shouldn't we be doing that? Because we know it's going to transform to +3. So wouldn't it be easier if we just started with that?
You can totally start with that. Not all the time that it's going to work out nicely, but yes, for sure. Okay, for sure. Then one more intercept. It's called a what? Y-intercept is when x equals to 0. Y-int when x equals to 0. So here we go. Y equals log base 6 of 0 plus 4 is 4. And then I'm going to add 3 at the end. Right now, I'm not concerned of you guys are using a calculator and punching this in. So guess what, guys? You get to leave it in its exact form, just like that. Okay? So that whole thing right there is an ugly decimal, and we're going to keep it in its ugly form. So log base 6 of 4 plus 3, just like that. We have one last example. I will give you guys 2 minutes head start now to see if you can fill out at least the parent. I'm going to put 2 minutes on the clock so I can keep track of time. Log 2 times log base 4, yes. 2 times log base 4. 2 minutes. Once you have the parents, I want you to compare with your partner. Because if your parent's wrong, then you're going to have the wrong transformed, right? Okay, immediately, what are the 5 x values, guys? For the parent. 116.
104, 116.
Yep, 116, 14, 1, 4, and 16. Your a value is 2, your h value is 5, your k value is negative 7. Okay, so we're going to have 2 times y, x plus 5, and minus 7, I'm sorry, over here on the output. What are the 5 new x's? Give it to me.
5 and 116.
Yep.
5 and 4,
6, 9, 21.
What are the 5 y values?
Negative 11, negative 9, negative 7, negative 5, negative 3.
Then I'm going to start with graphing the asymptote. Where should we put it? 5, 2, 4, 5. I want to make sure I can count correctly. Okay. Then immediately I'm going to write x equals to 5 so I don't forget, and then NA for HA. Let's pop the dots. 5 and 116, and all the way down to negative 11. I can handle that one dot off the grid. 5 and a quarter, negative 9. 6 and negative 7. 9 and negative 5. 2, 4, 5. So that's all the space I have. I'm just going to stretch it right there. Did you have something that looked like that? Yeah, all right, H and K. Immediately I can fill in 5 comma what? Negative 7. I'm going to leave the x-intercept for now. Do we have any y-intercept? No, none. Okay. Domain, just like the other one, is from 5 all the way to what? Infinity. Range is always all rails. Increasing, also from 5 to infinity. That means if everything's increasing, do we have a decreasing interval? No. Rate of change, we're going to write Varies, and this is 1 to 1. I have 3 transformations before I go and look for the X-intercept, because that's easier to find. The transformations are what?
A vertical stretch by 2.
Vertical stretch factor of dos. To the right by?
3.
Right by 5? Right? Right, 5 units. Down by?
7.
Down 7 units. Okay, the only last part we have to find is what?
The X-intercept.
Yeah, did you guys find it already? No? Okay, let's work it out together. 0 equals 2 times log base 4 of x minus 5. Subtract 7. First, we're going to add what? 7. So 7 equals 2 times log base 4 of x minus 5. Divide both sides by? 2. 7 divided by 2 equals log base 4 of x minus 5. Can I distribute log ever? No. So now, how do we isolate x? Exponent. Here we go. 4 to what power? Oh yeah, 7 over 2 equals x minus 5. I'm going to add 5 to both sides. Would you guys agree? In addition, I need to compute this out. How do I do that? I'm going to rewrite as radical. 4 to the 7 halves is technically square root of what?
4 to the 7.
4 to the 7. Can I simplify that at all? How many 4s can I take out? 3. I can take out 4 to the 3rd. I'm left with square root of 4 plus 5 equals x. What's 4 to the 3rd, y'all? 64. What's square root of 4? 2 plus 5 equals x. 64 times 2 plus 5 is 133. And that's how we find that one. 133, 0. And let me hand you guys homework 10.